Hi everyone. So we continue the section of increasing and decreasing annuities and perpetuities, the 4H. So the corollary, but before that, we want to review the theorem the last time. So we defined the increasing annuities by this cash flow. So the payment, we have one payment per year, and the first payment is $1, and the amount is increasing by $1 each year. And the accumulated value of this increasing the cash flow is named the IS right angle N. And we proved that this IS right angle N is equal to 1 plus I times S right angle N minus N over I. And other quantities such as the present value of the same cash flow or the present value of the annuity due version and also the accumulated the value of the annuity due version are also available. Yeah, so we proved the theorem, but actually to apply the theorem to real problems, actually it's more convenient to memorize this corollary rather than the previous theorem. Okay, so the corollary is a little more general. So suppose we have time 0 to n, and think about the cash flow of the P dollar at time 1 and P plus Q dollar at time 2 and P plus 2Q dollar at time 3 and so on. So the last payment at time Q, time n, is the P plus n minus 1 times Q. So the initial payment is P and it increases by Q each year. And we want to derive the present value of this cash flow. And actually this cash flow is equal to P times A right angle N plus the Q times A right angle N minus NVN, N times the V to the power N over I. So here the annual effective interest rate is I and is constant. So with this, the increasing annuity is just a special case of P is equal to 1 and Q is equal to 1. Okay, so proof. So we decompose this cash flow into the summation of two cash flow. So one cash flow is the constant cash flow of P minus Q. And another cash flow is increasing annuity with increment of Q. So the first payment at time 1 is Q, and the second payment at time 2 is 2Q, 2 times Q, and 3 times Q up to n times Q. And the first one is just usual, the annuity immediate, and the second one is Q times increasing annuity. So using the formulas we have, that we can prove this formula. Okay, so now that we calculate the present value. So present value, PV, is equal to the PV of this cash flow plus the PV of this second cash flow. And the first one is usual annuity immediate. So this is P minus Q times A right angle N. And the second one is increasing annuity. So this is equal to the Q times increasing annuity. So IA right angle N. So yeah, so this becomes, okay, so just we leave the first one as is, the P minus Q times A right angle N. Then next one is from previous lecture, we proved that the IA right angle N is 1 plus I times A right angle N minus N times V to the Nth power over I. So now that we separate the P part and the Q part. So P times A right angle N plus Q times A right angle N minus N times V to the power N over I. So here you can see that the negative Q times AN cancels with Q times I right A right angle N over I. So this part disappears and it becomes the simpler formula. So this is the end of the proof. So now that we have the general case, so we can deal with the increasing annuity or decreasing annuity when Q is negative. So in general, if we have this cash flow, then we can calculate the present value as the P times A right angle N plus the Q times A right angle N minus N V to the power N over I. So it's a little complicated, but as long as you recall this, then basically you can apply this to all cases.